You know, the internet, it really does feel like magic, doesn't it? Information zips around the globe in what feels like the blink of an eye. But here's the thing. It's not magic at all. It's actually an incredible system of rules and logistics. So today, let's pull back that curtain and see how it all really works.
So yeah, think about that for a second. You click a link and a website from another continent just appears on your screen almost instantly. What actually happens in that split second? Well, we're going to follow the data and find out exactly what's going on.
So what's the secret? It's actually pretty simple. Every single device on the internet, from your phone to some massive web server, they've all agreed to speak the exact same language. They all follow this really strict set of rules called protocols.
And what's so cool about this is how much these network rules are just, well, they're like our own human conversations. You know how we need to know who's talking and who's listening, or maybe when it's our turn to speak? It's the exact same for devices. They have to identify the source and the destination, format the message just right, and get the timing of the delivery perfect.
Okay, to really get a handle on this journey, we're going to use an analogy that I think makes perfect sense. Think of it like an international postal service. See, when you send a request across the web, your data doesn't just fly out there. Nope, it gets packaged up super carefully for its long trip. And this whole packaging process, it's got a name: encapsulation. And the postal analogy works perfectly here. Imagine you write a letter, right? You put it in an envelope, then maybe you put that envelope in a box, and then that box goes into a giant shipping container. Each layer adds a different set of instructions for a different part of the journey.
All right, so let's look at the digital version of that. Your actual data, that's the letter. First, it gets wrapped in what's called a TCP segment. That's a layer that basically makes sure it gets there reliably, without any mistakes. Then that whole thing goes inside an IP packet. That's like the main shipping box with the final address on it. And finally, all of that gets wrapped in a frame, which is just the instructions for the very next stop on the journey, like from your laptop to your Wi-Fi router.
Okay, so obviously for this package to get anywhere, it's going to need an address. And the first, most important one is the big one, the global address, the one that points to its final destination, wherever that is in the world.
And that global address, that's the IP address. It's exactly like the full street address you'd write on a package you're mailing. It tells the entire network, hey, this is where this thing ultimately needs to end up. And here's the key part. That address gets slapped on the digital box right at the start, and it absolutely does not change for the entire trip. It's locked in.
But wait, that global address isn't quite enough on its own. I mean, the Postal Service also needs to know exactly which person, which mail carrier to hand the package to at every single step, right? Well, the internet needs that too. We call it the local handoff.
So this local hop-by-hop address is called the MAC address. Think of this one as the name of the specific mail truck that's just taking it to the next sorting facility. It's the physical, burned-in address of a device's network card. And the big difference? Unlike the IP address, this one changes all the time. It's only good for one single jump.
So when you put them side by side, it really makes it crystal clear, right? The IP address is the permanent address on the package. It guides the entire journey. The MAC address? Totally temporary. It's like telling the mail carrier, just get it to that guy over there. It only guides one little hop at a time and gets a new value at every single stop.
All right, let's put this all together. It's time to see how this actually works in practice. We're going to follow a single data packet on its journey all the way from your computer out to a web server. First up, let's look at the heart of the message, the packet itself. Inside, you've got the source IP, that's your PC, and the destination IP, the web server. And remember what we said? These are totally locked in. They are not going to change. They stay exactly the same for the whole trip.
Okay, now for that very first hop, let's look at the outer wrapper, the frame. The from address is your computer's physical MAC address. And the to address? That's the MAC address of your home Wi-Fi router. The package is literally just being handed off from your computer to the front door of your network.
And here, this is the really cool part. As soon as your router gets that package, it basically rips off that old outer wrapper, throws it away. Then it creates a brand new one. So now the source MAC address is the router's MAC, and the destination MAC is whatever the next device is on the path to the server. And this rewrapping happens over and over again at every single stop, all while that inner IP packet just stays there totally untouched.
So after all those hops, all that rewrapping, your package finally makes it to the web server. Awesome. But it's still covered in all those layers of digital packaging, right? So now the server has to do the exact reverse of what we just talked about to actually get to your message.
And yeah, you guessed it, this has a name too. De-encapsulation. It's just as simple as it sounds. The server gets the frame, it opens it up. Then it looks at the packet inside and goes, yep, this is for me. It opens that, checks the segment to make sure everything's okay, and finally, there it is, your original data. That data then gets handed off to the right application, like the web server software, so it can handle your request.
I mean, when you think about it, this whole thing is just an incredibly complex global dance, and it works flawlessly billions of times a second. It's nuts. Which kind of begs the question, right? Who makes all these rules? Who makes sure a phone made in one country can talk to a server built in another?
Well, the answer is a bunch of neutral, non-profit groups. You can kind of think of them as the guardians of the internet. You've got organizations like the Internet Engineering Task Force, they're the ones developing the tech. And then you have groups like ICANN, who manage the global address book. Really, their entire job is just to make sure the internet stays one, single, open, connected network that works for everybody.
And this quote really sums up their whole philosophy. Because all these rules are open standards, because they're available to everyone, anybody can build a product that connects to the internet. That's what sparks all the competition and drives the incredible innovation we see every single day. It is literally why the internet works the way it does.
So in the end, the internet isn't magic. Not at all. It's just the silent, constant, global conversation that follows a perfect set of rules. It's really proof that we can build these unbelievably complex worldwide systems that work for everyone. Which kind of makes you think, doesn't it? What other huge problems could we solve if we had a universal language like this? What's the next internet we need to build?